okay, what are the possible things that they might likely talk about? So one of the major things that would definitely come up would be the value that we would derive from statistics and data. So before I continue, I just wanted to check, is there anybody that in their work they use statistics and data? So I just wanted to know your experience. So what's your experience like? How has data helped you in any way?
Yes, for me, because I study demography and social statistics.
Wow.
So I deal with statistics and currently too, I do analysis. I still did some level of analysis yesterday
Wow. Wow.
for a report.
Wow. That's great. That's great. So thank you very much for that. So one of the major things that statistics and data help us to do is summarizing information, just as Faidat had noted. So, for example, I want to annotate here. For example, if I have one, two, sorry, don't mind my numbers. I'm writing like 1, 2, 3, 4. This sets of numeric figures do not make any sense, right? Until I give you what they do. And even when I give you what they do, it still doesn't make any sense if we cannot get any information from it. So if I add that this is the order in which people joined the class today. Sorry, don't mind my. So ORDER. So just mind my, don't mind my alphabet. Just take it like that. So if I say, okay, this is the order in which order in which people joined the meeting today, right? It now makes sense because we can get information from it. It makes sense when we can get information from data. It doesn't make any sense if we are unable to get any information from data. So if the only thing that we have been able to see is just 1, 2, 3, 4. What does 1, 2, 3, 4 mean? So let me pick up another number that is quite viral. But if we don't put, or if we're unable to put any information to it, it doesn't make sense. 1360 1421 1400 1393. So please, who can guess what I'm trying to do? Does anyone has any guess as to what I'm trying to, like, any information I'm trying to pass with all of these numbers? Anyone? Okay. Yeah, it's totally fine because what I'm just writing are just nonsense or would not make any sense if I'm not giving you context as to what I am writing about. So what I have just written about is the price of $1 conversion from $1 to £1 in the past few weeks. Or is it past few weeks now? Yeah, past few weeks, 2-3 weeks ago. As soon as I say, oh, dollar to naira conversion rate, then we can say, oh, wow, there is a decreasing trend, 1421 to 1400 to 1393, now to 1360. I think it dropped to 1340 at some point. Then now it's around 1360. So as soon as I put a context to that information, it then starts to make sense. And that's what the value in statistics and data is. That's why Faidat said she analyzed data and was able to get information from data because she wants to summarize information. That is why, as a result of drops in Naira dollar exchange rate, the CBN said, now we want to drop rates. So the first, and that's why I'm taking my time on this slide. I might not take my time on most of the other slides that I have after this, but the major thing that I want to pass across in all of today's session and even in subsequent sessions is just that numbers in themselves do not make sense if we are unable to glean insight from it, put context to it, and make use of them in our decision making, in developing policies. And that's why I find it so disheartening that most of our policies in Nigeria are actually not based on data, like most. I find it so hard to believe that we are in the big 2026 and we still make decisions based on general knowledge. Like most of our policy decisions are based on that, and I don't know when we're going to get it right. In terms of the utility of statistics and data in sphere of life, actually there is no sphere of existence that data is not needed. There is none. There is none. There is none. There is none. Virtually none that data is not needed or that we can get data from. There is no process in this world that we cannot get data from. So just tell me anything that is constantly moving or that we can put context to, we can get data from that process. And once we can get data from that process, we can summarize information about that process and we can make decisions about informed decision about that process. Then develop policies about it, make decisions, then turn any form of uncertainty that we have into insights. So data gives us the information, the evidence to make right decision, not just guesses, not just guesstimating, not just trying to see, oh, this is what will happen. Even in our relationships, people also make use of data. It's like, what are the red flags? It's not at night. He doesn't call me. Those are data points. Those are data points. They say, oh, no, I don't think I can spend the rest of my life with this person. So now you are you are making a decision. So at every point when you ought to call, he didn't call, that's a data point. When maybe probably he cheated, that's another data point. Probably what he ought not to get angry about, he got angry about it. That's another data point. Perhaps she asks, she requests for bones trades yesterday, and today she's requesting for trip to Bahamas, and the next day she's asking for some exorbitant and pricey items. Oh, that's another data point. Then you now came to I was uncertain about what the future is going to look like with this person. But with all of these data points, then I know that I'm not guessing. This person is not for me. And on the flip side, oh, this person is sweet. That's a data point. Whenever I am feeling overwhelmed, she's always supportive. Oh, that's another data point. Oh, whenever I need someone to talk to, he's always there. That's another data point. He's my go-to person. That's another data point. Then all of these data points then moves us from just guessing about what your future will look like with that person to the point where you say, oh, I'm not guessing again. This is the right person for me. So that's just the major value in statistics and data. So I think that will be all for now. Any question? Any question?
No, sir.
All right. So all through this, all through the course of this program, we are going to be talking about different arms of statistics. And it's important for us to understand those the principles that form the bedrock of statistics, which we are going to be, making use of over the time. So most data analytics and data analysis career stops at more of this and some level of this. Once you start core data analysis, data analysts, perhaps probably in research industry, in the academia, then you make use of all of this up until this. And all of those forms the bedrock for data science, machine learning, big data, and every other data oriented field. So most of our Excel classes will be on discrete statistics and differential statistics. Most of our Power BI courses and topics will be on those. So for those that just want to have their career in data analysis and data analysis, well, that's like, okay, I'm good to go. At least I have friends in the UK, in the US, that's just what they do in their firms. Yeah, that's what they do. And I have friends in Nigeria who are working with international organizations and even organizations in Nigeria. That what they do every day is just discrete statistics and differential statistics, right? They are not testing hypotheses. And that's what they do. That's what their career is all about. So if you are not really interested in SPSS or R, then you don't have any problem. So Excel and Power BI is enough. But in terms of the core principles of statistics, discrete statistics is the first, That's like the bare minimum. Then after descriptive statistics, then we start talking about inferential statistics. Inferential statistics at the beginning is based on probability estimation, which we might still talk about and leave some parts. But once we start to talk about core inferential statistics, then we start to talk about hypothesis testing and sampling. So I will not spend much time on them because we are going to continue to make use of them. So we are definitely going to be referring back to them every time. So in this statistic, what we're just doing is we are describing. So I have data on probably age of people. So I have 23, I have 24, I have 17, I have 19, then I have 30. So 5 people were in a meeting, and this is their respective ages, or this is their respective age. I'm not a grammatical person, so I might always bore you with my English or my grammatical structures. So now, these are their respective age, and we've gotten this information from them. What this game statistics does is to help us have like a summary of what this data set looks like. So I can say, okay, I want age. I say I want age. I want average. So what I want is average. So what is the average age of those folks in the meeting? Or I can say I want a mode. Mode is also an average. So we're going to talk about that. Or the standard deviation. Whenever I'm doing all of this, I am only describing the data, or probably the total age of everybody, the sum of all their ages. So we can see that what I'm just doing with all of this is that I'm just describing. I can even say, okay, probably there are more than about 20, 30, 50. I can start to say I want to plot a graph, a bar chart. So now I have something like this, something like this. I can now say, oh, this one is the highest, this one is the lowest. So notice that we are only describing. We are not doing any other thing. We're just describing what the data looks like. So that's why I said things like Power BI sits at the realm of descriptive statistics and small of inferential statistics. Because in Power BI, what we're going to be doing for the most part is just to describe. So we have our data sets, then we describe what data set looks like. So we are going to develop charts, develop this, develop that. So just to describe the data. Then when we get to inferential statistics then moves away from just describing. Now we want to understand, ask questions using our data. We want to ask questions using our data. So we have collected data from a particular process. Now we want to maybe generalize or predict or model or test some hypothesis. And that's where inferential statistics comes in. Under inferential statistics is largely based on probability. You all know probability. Probability is the is the likelihood of an event happening or not. Then estimation, we are going to estimate. We have point estimates, interval estimates. We're going to discuss that one, those in good amounts once we get to SPSS-R, because by that time we're going to be setting up our hypothesis and testing our hypothesis. Then the last part of it is sampling, where this is the core of everything we are doing here. Sampling gives us like the avenue, the leverage to do all of these that we have here. because we cannot collect data from every item in the process that we are studying. Whatever it is we are studying, we cannot collect data from everybody. And because of that, sampling gives us an avenue to collect data from a small set of that process, then make generalization to the population where we have collected those items. So that's what I'm trying to pass on this slide. Any question? Any question?
No, sir.
Okay. All right. So we talked about the values in statistics and data. We talked about the core principles of statistics. Then why are we even collecting data? I think I've overflowed this, so I'll just brush through. So we don't need to like really talk about it in depth here. So just for the opting time, the major reason why we are all here to learn about data analysis is because we know that data will be gathered somewhere and we need to analyze those data. And the major reason we analyze data is to get information. I think I've said that over time on this call. Then when we get information, the next thing we want to do is to be able to make decisions from that information, to plan with that information, to estimate with that information, to forecast with that information, and to model with that information. So all of these come from the data that we've gathered. So when we collect data, our aim is to first glean information from the process, make decisions with that information, plan with that information, estimate, forecast, and do some modeling. And now, the world is now getting very beautiful with AI and all this agentic AI and AGI and the likes. And several questions are coming up about, okay, what will happen to people? Would AI take people's job? Let me just even like check our pulse. Do you think AI will take your job? So let's hear from everybody. Do you think AI will take your job? Okay. Shakira said no. So who else is going to talk? Do you think AI will take your job? Let's talk now. Hello? Can everybody hear me? Ajalu Abuli said no. So who else is going to say something? Okay, Favor said no. Okay. Yeah, you are all saying no. Why? Why do you think AI will not take your job? All right, so let me finish my class, then we'll have time to discuss that. So I'll put that in the back burner, not the front burner now. All right, so next thing I want to talk about is sources of data. So I'm not going to spend too much time here also. So source of data just talks about where data is coming from. Where data is coming from. For people that work in the research industry, in the academia, with consultancy organization, or that are working in consultancy organization, they are doing something around health, public health, all of those, market research, we are going to meet it with a lot of primary data. For people that would work in probably retail, working with FMCG for data analysis and the likes, then you might be working with more of secondary data. So what is a primary data and what's a secondary data? What is this primary source of data, and secondary source of data. So it's just talking about how data was collected and the usage. So if I collect data for a particular reason and I'm using it for another reason entirely, then that is a secondary data. But if I'm collecting data for a particular reason, I am using it for that reason, then that's a primary data. That's just the distinguishing factor between the two. It's just how it was collected and how it was used. So if it's collected for a purpose and you are using it for that same purpose, then that is primary data. But if it's collected for a particular purpose and you are using it for another purpose, that's a secondary data. So that's just the difference. So I need to spend too much time there. Then what are the common data types? So when we collect data, they come in different types. So let's say I collect data on age. That cannot be 23.5, right? Except for people that were born on leap year day. That's February 28th. I mean, February 29 rather. So you can see that age can never take on decimal place, right? That's integer. So integer are whole numbers. There are some variables. So for each variable, it follows a data type. And we're going to make use of that when we start working with Excel, and it's very important that even if you are in this class, it's very important that you go back to the video and look at this again and again and again. And if you have any question, please ask. I don't like the way you are not asking questions in this class. When we get to practicals, I will not go back to what I've said before because I've given everyone the chance to talk and ask questions now. All right. So integers are whole numbers. So for each variable that you are going to use, so okay, let me just say it like this. So data set. So this is we have overflowed the issue of data, right? So this is you have collected data. This is data. What constitutes data? You have some information that you collected from a process. So maybe this first information is height of people. Their height. Then another information you collected is age. Then another information you collected is the gender. So notice that when I collected this information, I have more than one thing that I've collected information on. For each of them, we call it variable. Why do we call it a variable? It's just contextual. Variable. I think the smart dudes that came up with this name, they really tried, right? so when you see variable, it's just I change this I to Y and say variable. It can vary. If it cannot vary, then it's not a variable. So if we come to this class, and we say, okay, we want to take the height of everybody in this class, you find out that everybody will have different heights. Some people would have the same height. Some people, so at that point, they have the same thing. But for the most part, people will vary in their height. If you take the weight of people in this class, the same thing would happen. We would have people that have more than 60, between 50 and 60, 50 and 55 kg. So people would vary in that regard. Also, if you take people's age, people will vary in that regard. So that's why we refer to it as a variable. So when we collect information about many variables, then that's what makes up our data set, our data. So I want to make that connection before we continue. So a data set or data is or constitutes of one or many or one or more variables. So one variable, you can say, okay, my data is just data on stock price of a particular company or product in Nigeria. So if it's stock price of Dangote in Nigeria, oh, no problem. So if my data is just the number of registered companies in a country in the world, so I take Nigeria, this number of countries. I take Somalia, this number of registered companies. Nigeria, number of registered companies. All of the 100 and something countries in the world. I take each country, number of registered companies. Each country, number of registered companies. Each country, number of registered companies. Then I have country and I have number of countries. So number of registered companies. Then I have a data set. Notice that your data set can have just one variable and you can have more than one variable. So that's just the distinction I wanted to bring out before we continue. Then for each variable, it would have its own context, what it looks like. And what it looks like is what we refer to as data type. So each variable has its own data type. So for integers are variables that take only whole numbers. We can't say, oh, my age is 22.2. No, can't say that because age is an integer, it's a whole number data. We cannot say that my gender is male.2. Why? Because gender is categorical. You can only have levels, male or female. And in advanced world, we have all of those rainbow colors. All of the rainbow colors then follow in the advanced world. There's this research where they say that gender is continuous. Like there was a research I was reading saying gender is continuous. That was in the advanced world, but in Nigeria setting, gender is binary. That's male or female. So now, data can also, or a variable can be decimal points or a real number that can take on both, that will have both the integer part and the decimal part. Then we call it either a float or a double. Variable can be a character, just perhaps one alphabet, or a string, which is group of alphabets, or a boolean, true or false, or an array bringing up of more than one number or more than one data type. No, array is combination or group of group of data points with the same data type. So we can have an array of characters, we can have array of integers, we can have array of characters. So we can notice that it's the same data type, but we have more than one information. Then we can have variable that's in dates, we can have variable that is in time, we can have variable that is in date time, and we can have variable that is not a number, any. We're going to be seeing more of this when we get to missing data in R and SPSS. We're going to be seeing NaN and Na. So when we see NaN and Na, that means that that point is missing. So there are some processes that will generate missing data. And as a result of that, we want to ensure that our data captures all of those dynamics. So that's about that. So the next thing I won't talk about is type of variable. So I've talked about variable. So a variable can be qualitative or quantitative. So it's qualitative, then it's not in number form. Then it's qualitative. If it's qualitative, it's not in number form. Then if it's quantitative, it is in number form. That's just the difference. There's no any points. So the next thing I want to talk about is levels of measurements. And this is very important because whatever it is you are going to do in data analysis, you have to understand all of these levels of measurements. So when you collect data, they fall into either of these measurements, either of them. So it's either the data is nominal, ordinal, or interval, or ratio. So what's the nominal data? So if a data or a variable is of measurement nominal, it means that that variable only has levels that do not have any inherent ordering in them. So let's take an example. If I take variable of the colors we like, so everybody drop the color, your favorite color on the group chats, on the charts. Let's see people's colors. Your favorite color, please drop it on the charts. So we have blue, we have white, white, blue, yellow, navy blue, black. So now, if I am to order these colors, do they have any inherent ordering pattern that, like, in them, I can say, okay, this is how, like, anybody seeing these colors, would they be able to, like, put them that this one is the one that will come first, this one is the one that will come last? You notice that it's won't be possible. Why? Because colors do not have any inherent ordering in them. So now let's take another example, right? Let's take another example. Let's take, everybody just drop any number that you like between 0 and 9. Just drop any number you like between 0 and 9. Someone has dropped 1, someone has dropped 7, someone has dropped 3, 5. Now, you will notice that what you have dropped now, can I order it? Do they have inherent ordering? Without just looking at those numbers, can I order them? Can I put them in an order form? Yes. But you notice that when you gave me colors, colors cannot be ordered. Colors cannot be, like, they don't have inherent ordering in them, inherent ordering pattern that even any a 5-year-old can say, okay, this one comes first. A 7-year-old can say, 1 is the first number now. 26 is another, it comes after 1. You get, but blue, navy blue, unless you say, okay, I want to order by alphabet, first alphabet. But naturally, the variable does not have any inherent ordering. So if a variable do not have any inherent ordering, then we say the variable is nominal. If the variable has an inherent ordering, although it's categorical, but it has inherent ordering, then we say it is ordinal. You can see order, O-R-D, order. So that was how I actually used to understand them. The first time I understood them. So ORD, order, you can order them. That's what I use. The nominal, you cannot be able to order them. Now, nominal takes, okay, they are categorical in nature, but you cannot order them. But now, when we get to ordinal, yes, they are categorical, but we can order them, right? So now, what is interval? Interval can be ordered. There are numbers that can be ordered, but the difference in them do not make any sense. So if I say, okay, Is there anything like zero weight? That okay, zero weight means the absence of weight. No, doesn't make any sense. Zero temperature doesn't mean the absence of temperature. No. So when you take a variable that you are measuring and you cannot say that the absence of that variable or zero in that variable makes any sense, then that variable is an interval variable. So temperature, zero temperature is still a temperature. So does it make sense? Yes. But does 0 kg in weight means there is no weight? Doesn't really make sense. So you can see the difference between them now. Although interval and ratio are always very dicey to piece out. So most times we really don't talk about them that much, but then it's just for general knowledge. The major ones that we need to know, because even in some software they use the same thing for interval and ratio, but the difference or the major difference is in nominal and ordinal. Please, if you have any question, just let me know. Is there any question? Is there any question? So notice if I take data on blood type, we are still going to, once we are back from our first break, we're going to look at different questions. So if you take data on blood type, you notice that there is no inherent ordering in them. But if you take data on body temperature, there's inherent ordering. But 0 makes sense in temperature, but 0 does not make sense in weight. That's just the difference between those two. The next thing that I just want to talk about is, so these ones are just things that we know. It's not, we don't really need to say much about them. Data sources, where we get data from. So for primary, we get data from questionnaire, interviews, focus group discussions, in-depth interview as part of that. These are just things that we can just Google and make use of. So they're just talking about how we get data. So for secondary source of data, libraries, online, offline, website, this channel, archives, publish reports. In the cloud, cloud is like the next big thing because all of our data is stored in cloud. All the data you are putting on Zoom, Google Meet, WhatsApp, Twitter, and all of those, they are stored in cloud, where people can then make use of those data and analyze and get information. I think this is where we're going to be ending this first session, so everybody can go and rest. So everybody can go and rest for now. Then we'll be back in the next 15 minutes. So please, if you have any question, we're going to be discussing your questions as soon as we resume. Please don't tell me you don't have any question. No. Please don't tell me you don't have any question. So once we are back, we are going to go through your questions. Thank you.